Okay, folks, here's equation 4 again. This time we're looking for solving for. Oops, I'm moving stuff around here. We're looking for v. So equation 4, if you don't remember, is this one right here. And so it's going to be something where. Oops. It's going to be something where we don't require any. Where we require no time. So then, in other words, since we're going to be looking for v, the final v, I need to know what speed it started at. I need to know how fast it's accelerating, rate, like how much it's changing its speed, a, and I need to know how far it's going to be going, and then I can figure out how fast it's going at the end. So I came up with an equation that has that stuff, just like I'm asking you guys to do every day. Come up with an equation. All you got to do is, you know, give everything else except the thing you're looking for. Here we go. Let's get started here. A car accelerates from rest, so initial velocity is going to be 0 meters per second. And I think I'm going to start darkening my brush size a little bit. And then at a rate of 5 meters per second, oh, that should have been squared. How come it's not writing now? Oh, ink flow. What the? There we go. Let's go. Ink flow 100%. So, yeah, because it's accelerating from rest at a rate of this. So, if it's accelerating at a certain rate, I need meters per second squared. I just screwed up with that. So, acceleration is 5 meters per second squared. Initial speed is this. And how fast is it traveling? How fast is it going after traveling 100 meters? So it traveled 100 meters. That's the change in position. And they want to know how fast it's moving at the end. So just regular v. Remember, regular v is final v. So we're going to use that equation, and it looks like this. Plus 2a, and then the delta x thing here. And let's plug everything in that we know. So we don't know the v. We'll keep it squared. We do know initial velocity is 0 squared. If it does give you what speed it starts at, just plug it in here and square the thing. That's all you got to do. No big deal. Plus 2 times a, the acceleration rate was 5. And delta x, the change in position, was 100. And did I miss a squared anywhere? Nope, I got all that stuff. Double check yourself. Make sure when you're doing math that you're squaring where you're supposed to and all that stuff. Because that's easy to forget, just writing down numbers and forgetting those little squares or something up there. Let's see here. That's going to just disappear, so we don't have to worry about it anymore. And 2 times 5 is 10, and then this times 100, and that's v squared. And then 10 times 100 is 1,000, and then v squared. And so if the final speed, when you square it, it's going to equal 1,000. But I don't want to know what happens when you square it. I just want to know what the final v is. So I'm going to have to square root that, and that'll turn that to a v. But remember, whatever you do to one side, you got to do the other. So I'm going to square root that side. So the answer is just the square root of 1,000. Well, let's figure out what that is. Clear 1000, and square root button right here. 31.6. Sounds good. 31.6 meters per second. That's your final speed. And that's it, folks. Simple as that. No trickery here. I wonder if there's an alternate way I can do this. I'm trying to think. Actually, I don't know if there's a real fast proof way I could do it. There is, but I don't want to overcomplicate things. So let's just stick to this and just write down the equation, plug it in, do a little bit of algebra, and you're done, okay? So go ahead and do some practice problems.